All right, guys, good afternoon. So we're going to work through this paper, the January 2023 paper. As you know, the pass mark, I don't want any talking. Pass mark is 85%. All right? Till from now, on Saturday, we're doing 2 papers. On Saturday, 2 full papers. I'm going to do the first one. You're going to do the first one. I give you the solutions. You check through the solutions. And I will only do questions that you get wrong. All right? Or that you want me to explain after I give you the solution. Then after that, I'm going to give you a second paper. And the same thing again. I'm going to do it 2 hours, 40 minutes. I'm going to do that second paper. And then after that, I'm going to give you the solution again. And then I'll only do questions that you want me to explain. All right? That's the process for Saturday. Sunday is a day for everybody, really. Because Sunday is like a freelance day where persons will come and ask for questions to be done. One last chance for me to explain questions, really about questions. Can't teach anything from scratch again, so it's really about explaining the solutions for questions that you would select. And you can basically select questions from the past papers. I would advise you to select past paper questions from 2024, January 2024, all the way down to about 2015. Don't really need to go beyond that for this exam. All right? And I'll go through those questions one last time for you. The session will start at 11 and end at 4. And I'll also give instructions on that day how to proceed from that point to the exam. All right? And it's very important that you follow those instructions. All right. So that is that. Just wanted to give you that little intro before we get into the paper. So this is the paper that you all did. And the pass mark is 85%. So let's see how well you did on this paper. We're going to do another assessment this week. All right? Because I was not pleased with the assessment last week. So we're going to do another assessment this week. One last bite at the cherry to see where we're at before the real exam. All right, let's go. So, January 2023, very recent exam. So your exam that you're gonna get will be very similar to this one. First question, as usual, is for us to, well, it's telling us that by rounding, so it said this one is a little bit different for the instructions, a little bit different. It said by rounding each number in the expression below to one significant figure, estimate the value. So this one is not no calculator, nothing. Follow instructions. By rounding each value, what are the values? This 108, this number right here, and this number right here. Round each of them to one significant figure, and then estimate the value. So not a calculator question, this. All right, so ready, let's go. So if you're rounding each figure to one significant figure, this 108 to one significant figure becomes 100. Because the first significant figure is 1, you change all the values after that to zeros. All right? Because this 0 cannot increase the 1. So this then is going to become the square root of 100 over. This now, to one significant figure, this 1 is the first significant figure. You're going to use this 9 to correct that 1. It's going to change it to 2. So this is going to become 20. Correct to one significant figure. And you can know 19.7 is about 20. Plus this 5.29 corrected to one significant figure. This 2 cannot change that 5. The 5 is the first significant figure. So to one significant figure, that 5.29 becomes 5. Then we proceed. The square root of the 100 up here is just 10. Under here, this becomes 25. And if we divide this down, 5 into the 10 goes 2 times, 5 into the 25 goes 5 times. And that is the answer you're supposed to get. 2 over 5. That's how this question is done. I think this was the only time they set one like this. Anybody got that? Huh? All right, good. Let's continue. Next part says, find the exact value of this. The thing about it, it did not say use a calculator. So therefore, I'm going to go step by step because it did not say use a calculator. All right? So when you're working these out, remember, you have to do the expression in the bracket first. I'm still going to use a calculator to work out what's in the bracket, you know. But I'm going to kind of go step by step because you can use a calculator in the exam. All right? So this becomes as an improper fraction. The 8 times 3 is 24 plus 3 makes 27. So this fraction becomes 27 over 8 divided by, and I'm going to work out this as a single fraction with the calculator and see what I'm dividing by. So it's a fraction 5 over 12 plus a third. And that is 0.75 or 3 over 4. So this becomes 3 over 4. So divide by 3 over 4 is to multiply by 4 over 3. So this then is the same as 27 over 8 times 4 over 3. And then it basically cancel down the value, but I'm going to put this in the calculator. And it's a fraction 27 over 8 times a fraction again 4 over 3, which gives me 4.5, which is 9 over 2. And I must write it as a mixed number. See that? So 9 over 2 is the same as 4.5 as a mixed number. So this is what they're looking for, 4.5. Huh? You put on the calculator, you get this. I guess maybe you will, but just because it did not say use a calculator, that's why I said, let me show some steps. All right? Show some steps. And it's all 3 marks for it. So I think it makes sense to show some steps for this one because it did not say use a calculator. So if it don't say use a calculator, you need to show some steps. Show some steps. Like for example, I'm showing that I know that I need to work what is in the bracket first. I have to work what is in the bracket first. All right? And then remember now, when you divide by a fraction, you invert and multiply. So you show them that. But what you could do, you could put this in the calculator and see if your final answer is the same. That's what I would do. Show the steps, but then test if my final answer is the same when I'm done. But that is it. 4.5, and I want it as a mixed number. So you have to give them this. Don't give them 9 over 2. All right, that is that. Next part says, due to the COVID-19 pandemic, the number of available seats in a hall was reduced from this amount, 125 to 93. Was reduced from 125 to 93. Calculate the percentage decrease in the number of available seats. So the percentage decrease is simply the decrease divided by the original amount multiplied by 100. Let's write out decrease. It's a decrease divided by the original amount multiplied by 100. What is the decrease? I don't need to know the actual decrease. I'm going to put it in the calculator. The decrease is 125 minus 93. The original amount is 125 multiplied by 100. That is the percentage decrease. So I'm just going to put that in the calculator. 125 minus 93. I put that over 125, and then you put that as a percentage by multiply by 100, it is 25.6. So this is equal to 25.6%. Yes? No, this is an exact answer, my boss. So because it's an exact answer, you give an exact answer. If it is not an exact answer, then you round it up. But that's an exact answer. If it was 25.61238 and so on, then you could go to 26. But generally speaking, still, you must give your answer to 3 figures, 3 significant figures, if they don't tell you the level of accuracy. I repeated this thing from September. till now. If the question don't tell you the level of accuracy that you must give your answer to 3 significant figures. I don't need to say it again. I've been saying it since September till now. So people are asking me, oh, you must give your answer. That don't make no sense at this stage when I've been saying the same thing over and over and over again. It's not a guess and spell thing. If the question don't tell you what level of accuracy to give and the answer is not exact, in this case the answer is exact, 25.6, so put the 25.6. But if the answer is not exact and them don't tell you the level of accuracy to give, then give it to 3 significant figures. Understand that? But this one exact, so why correct it? There's no need to correct it. It's an exact value. So just put the 25.6. In addition to that is 3 figures. Good? 25.6. Don't give away your marks, man. Don't give away your marks. It's 25.6. All right? Next question says, Mika invests a certain amount of money in a bank that pays compound interest at a rate of 2.5% per annum. 2.5% per annum. Compound interest. At the end of 2 years, the value of our investment is this. So after 2 years, this is where the investment reached. That is the amount in there. After 2 years, so time is 2 years, the percentage rate is 2.5%. That's the information. It says calculate the amount that she invested. That is the principal amount they're asking you for. And they're helping you. They give you a formula for compound interest, which is this. And they tell you what each thing is. A is the amount after n years. So this is the A in this formula. This is the A. Let's identify each thing. Then they tell you after n years, n is the number of years. So this right here is your n. The 2 years is your n. So n equals 2. This is the n in the formula. Then the principal amount is what they want, calculate the amount you invested. So this question is asking you for P. This question is asking us for the P, the amount invested. Then the rate is 2.5. So this is your rate. This right here is your rate. So this is your R, 2.5. The percent part of the R is already taken care of by the 100 on the year. So the R is in value is really 2.5. And all we need to do now with this expression is put all those values in it, and we are trying to find the P. That is it, We're trying to find the P. So plug in all the values in that formula, and then we try to find the P. That is all we have to do. So see here now, the amount after the time is this. So that is 7564.50. I don't have to put the dollar sign. When I'm done, I put the dollar sign. Is equal to the principal amount. I'm going to put P for the principal amount, which is what I'm trying to find, into 1 plus, and we're going to put 2.5 over 100. The rate is 2.5 over 100, and the number of years right here, so it's 2. They put a square on this. I'm solving for P. Easy, I have your BOSE calculator. To get the P, I'm just going to take all of this. I don't have to work it out, and just divide it under this side. All right? So the P then, when I take this and I divide it under here, the P is going to become this value on top, 7564.50. Let's put the dollar sign now. Over, I'll put it here as well. Over the whole of this expression. 1 plus 2.5 over 100 squared. Put all of that in a calculator and get your answer. Argument done. You don't have to work out the piece. Yes? But I just say you don't have to work it out, I still ask. Yes, you don't have to waste time and work these out first. Remember now, you're trying to limit the amount of time that you spend doing the exam, you know? So you don't have to work out information that is irrelevant. Your calculator can accommodate all of this. So why work out inside yourself first? For what? To waste time. The only reason to work out inside here so and the square and work out that value there is to waste time. No other reason. Because your calculator can take all of this. Don't waste time. Look, it's a small amount of space they give it to do these things. You know? So why waste time working out this value when we don't need it? We don't need the actual value of this. We don't need to know what it is. Just put all of that in the calculator exactly as it appears there. And press equal and you get the answer that you're looking for. Come on, man. You have to do the mathematics smart, man. Why work out a value that you don't need? I'm going to put a fraction 7564.50. I don't put the 0, but still, no problem. Over a bracket. Inside the bracket, I have a 1 plus. Then I have a fraction. I have a fraction again. I have 2.5 upon the 100. Come out of that, put back my bracket, and I'm going to square it. Square. 7,200. Easy. So my amount invested was 7,200. That's my answer. So I calculated one time. I only did one calculation. The least number of times you can touch your calculator when solving a question, the better. So you rearrange what you have until you have one expression that's going to give you an answer. Put it in the calculator. That is why your ability to transpose is so important. But if you feel more comfortable working out this first and then working it out step by step, no problem. Be my guest. But no, say you run the risk of not finishing the exam because you're spending too much time on one question. All right? Spending too much time on one question. All right. So that is the first one. So you got 7,200 already there. All right. Good. No problem. Just make sure you get the right answer. If you want to do it a long way, get the right answer. Here now, some simple thing. I don't think I need a calculator anymore. So this wants us to work that out. This is same as x cubed times x cubed. The square here is same as x cubed times x cubed. But you should know that if you raise a power to a higher power, you can actually multiply the powers. Yes, it becomes x to the 6th power. But if you never know that, you could recognize this as x cubed times x cubed. That's what the x cubed squared stand for now. And when you multiply numbers with the same base, you add the powers. So then it will become x to the 3 plus 3, which still is going to give you x to the 6th power. Then put this over here as an OR method. I don't want to look like this is because this is not the easiest way. The easiest way is just to realize that you multiply the values. This becomes x to the 3 times 2, which is x to the 6th power. That's the easier way to do it, rather than do all of this. So this is an OR method. This over here is OR. This is an OR method. Could do it that way. Down here. All right, so this is dividing. When you divide indices, you subtract the powers. Can we say that? Subtract the powers. So this becomes equal to y to the 8. Look carefully now. Minus, because we're dividing, and this power is a negative 5. So this minus becomes a plus. So it becomes y to the 13th power. See there? Y to the power 13. Because this becomes a plus. And put a plus on it. It's minus is a plus right here. So you add them. But understand that? Good. Nice and easy. Next one. They want us to factorize this thing. The only common factor in this thing right now is a y. So you take out the y. Factorize out the y. Out of this, we left with an x. Out of this minus y squared, we left with a minus y. That is it. Done. Then down here, we want to factorize this one. That's the difference of 2 squares. So this one is simply the difference of the numbers times the sum of the numbers. Look here, I told you one day in a class that you should get into the habit of putting the -1 in front. Why? Why do you put the -1 in front? Because when you do maths at a higher level, you'll have to do stuff like x cubed minus y cubed. And the x minus y will be in front. You have to do things like x to the 4th power minus y to the 4th power, and the x minus y will be in front. They will always set up like that. Just that they get long, they get more terms in here. I'm not going to get into it. So if I were to show you this one, for example, what you would get for this one is x squared plus xy plus y squared. That's what they're going to get. For this one, when the powers are 4, you will get x cubed plus x squared y plus xy squared plus y cubed. That's what you're going to get for that one. So this is a series of difference of powers that you'll have to do at odd maths and pure maths. All of them start with the difference of the numbers. You understand? So this that you're doing at CSEC is just the first level of it. The difference of 2 squares is just the first level of this difference of any 2 powers. Any 2 powers. They could give you x to the 10th minus y to the 10th. Difference of any 2 powers. And this is, again, is going to start with x minus y. In here, you're going to have x to the 9th, then x to the 9th, then x to the 8th times y, and so on. And then it continues. There's a pattern to it. All right? But that is for higher level maths. And that is why I tell you, write it with the x minus y. A lot of teachers teach them put the x plus y in front, but I'm preparing you for higher level maths. So I'm saying put the x minus y in front, please. For that reason, for when you're doing maths at a higher level, you have to do the difference of 2 powers, higher powers. But that is it. Then this one now says, hence, we are to solve this. So what this really then is a factor of the numerator that we did up here first. That's on the numerator. So this is y into x minus y over, and this on the denominator, the difference of 2 squares. X minus y times x plus y. And then what you realize now is that this x minus y cancels this x minus y. They cancel each other because they're the same. And so you're left finally with just the y up here over the y plus 1, the x plus y. That is it. But go to that. But I got that. Y over x plus y is the answer. All right, let's continue. Next question says, the diagram below shows two rectangles, M and M, with their dimensions expressed in terms of x. So this one is x minus 3 and 3x plus 4. This one is x minus 3 as well, and x plus 2. Question says, given that the difference between, stop talking please, the difference between the areas of the 2 rectangles is 64 centimeters square. Show this. So all we have to do is put the difference between the 2 areas equals 64 and simplify it, and we're going to get this. Now clearly the M1 is the larger one, right? So what they have basically said is that the area of the large one, which is x minus 3 times 3x plus 4. So here, x minus 3 times 3x plus 4 minus the area of this one, which is x minus 3 times x plus 2. That difference is equal to 64. Essentially, that's what they have said. And then all we have to do now is take all of this expression and simplify it down, and it's gonna become that. There are multiple ways to do it. I can first recognize this as a common factor and factorize the x minus 3 of those 2 terms. But I think what most persons will do is actually expand out this and expand out that and then subtract them. Right? But I think the easy way to do it is to recognize x minus 3 as a common factor. But let's do it the way that I think most persons will do, which is to expand out everything. So let's expand out this and put it in a bracket. Remember, you're subtracting everything that this is going to become. So this one is going to become And you must know is the x times the 3x is 3x squared. Then the middle term is the far product and the near product added together. Can we do that? The far product and the near product. Let me shift this down a bit. Start with the 3x squared here. Then the middle term, when you expand these two, is the sum of the far product and the near product. Look at it. The far product is 4x. The near product is minus 9x. Minus 9x and 4x, give me minus 5x in the middle. Come on, we have to do the math like big people. Minus 5x in the middle, minus 5x. Then the third term is this value times this value. Negative 3 times 4 is negative 12. That's what's in the first bracket. Minus, I'm going to expand the second bracket again. This x times this x is x squared. My middle term is the sum of the far product and the near product. The far product is 2x and the near product is minus 3x. 2x minus 3x is a negative 1x. That was negative x minus x in the middle there. That's what the middle term is. And then the third term is this second value times this second value, which is negative 3 times 2 is negative 6. All of that is equal to 64. Then now we're taking the terms in this bracket, minus the terms in this bracket. So let's do the like terms first. So it's 3x squared minus x squared. That gives me 2x squared. Then it's minus 5x minus a negative x. This minus becomes a plus x. So it's minus 5x plus x, that, which is negative 4x. Minus 5 plus 1 is a negative 4. Negative 4x. Then it says negative 12 minus a negative 6. Again, this minus becomes a positive 6. So it's really negative 12 plus 6, which is negative 6. So I'm getting negative 6. And that is equal to 64. I'm going to transpose now. I can divide 2 by 2 if I want to know. Right now, because each term can be divided 2 by 2. So I can divide 2 by 2, or I can transpose this first. Let's divide 2 by 2 first. So if I divide 2 by 2, make this smaller, because you see, they don't give a lot of space for these things. So divide 2 by 2, let me write it, divide 2 by 2, to simplify it, by each term can be divided by 2. Divide this by 2, it becomes x squared. Divide this by 2, it becomes minus 2x. Divide this by 2, it becomes negative 3. Divide this by 2, it becomes 32. So you must see it now. This 32 is going to come over here as negative 32. The negative 3 and the negative 32 is going to become negative 35. So you're going to end up with x squared minus 2x minus 35 equals 0, which is the same thing that I have here. So that was shown. See, they're shown. It's in a different color, the word shown. That was shown. Anybody got it? Huh? All right. Let's continue. The paper is in the group, my boss. Yeah, I can't get it now. I do the class now. I get it afterwards. Right. Next question. So this question is an interesting question. I can tell you from now. This is a special question. You have to remember this question. Just in case you get one like it again. I'm going to show you a part of it that is special. Okay? And you have to remember it. Because they don't set these things very often. The things that they don't set very often, you have to remember them the one time you see them. Because of all the 24 past videos that we did, this was the only one that's what we had to construct to find the center of a rotation. Because from this to this is a rotation. You get me? All right, let's do the question. I remember it. As soon as I see it, I remember it. This question says, The following diagram shows three quadrilaterals P, Q, and R on a square grid. Q and R are the images of P. So it's that this one is the original object. It's mapped onto this one, which you know is an enlargement, and also mapped onto this one, which is a rotation. All right? I'm naturally going to ask you to describe it. That's how these questions are all the time. Two different transformations. Question says, on page 9, draw the image of P. And I want us to draw this triangle. Draw the triangle under this translation, the translation of this. Now, what would this translation do to P? This translation will move it 10 units to the right because of this 10, and 4 units down. 4 units down. That's what that translation will do. Move it 10 units to the right and 4 units down. I must label it P prime. So let's follow the instructions. 10 units to the right, 4 units down, we're moving the P. All right, so this is the P. We're moving it 10 units to the right. Now, the first thing I want to do is check the scale. So on this scale, let me do this in red. Every centimeter is 1 unit horizontally. On the vertical, every centimeter is a unit as well. Okay. All right. So let's say we move this point. We just need to move 1 point and then draw about the same shape around that 1 point because of translation. So this point, we're going to move it 10 units to the right. So right now it's at -7, you know. If we move it 10 units to the right, we're going to go back to +3. But let's count it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. See? Goes over to +3. See there? +3. Then we need to move it 4 units downwards. 1, 2, 3, 4. That's the -4. So this point is coming to right here. So we can put that image point right there. Then once you put the point there, you just need to draw about the same shape around that point. So these two diagonal pieces at the top, draw them back here. And these two longer diagonal pieces, you see, there are 2 down, 1 back, 2 down, 1 forward. So 2 down, 1 back. So this point is coming all the way down to here, and this one is all the way down to there. That is your P prime. After the translation, 10 units to the right, 4 units down. Everybody go to that? All right, beautiful. So we can take this off. Okay. The next one is for us to do a reflection in the line y equals x of I'm labeled P prime. You have to know that the line y equals x is really the x-axis. That's a key thing with this one. The line y equals x is really the x-axis. So you're reflecting the triangle P in the x-axis and going to label it P double prime. Remember, when you do a reflection, image distance from the mirror line equals the object distance from the mirror line. All right? The key thing here is that the line y equals x is the x-axis. So you're reflecting in this x-axis now. So you're reflecting this in this x-axis. See the x-axis there? Let's do it in blue again. So this point first, for example, it is 1, 2, 3, 4 to the mirror line. It's going to go 1, 2, 3, 4 on the other side to here. That's where that point is going. Do it 1 point at a time. Then this point is actually 2 more than it. It's going to go. This is 6 to the mirror line. It's going to go 6 to the other side, down to here. All right? And then this point, it is 5 to the mirror line. No, 6 to the mirror line. Well, I'm calling something right. This was 4, or this was 7 to the mirror line. 7. Or this not the wrong. This not the wrong place. This is supposed to be here. Okay, this length is 3 units. See it? 1, 2, 3 units. So this was actually 7 to the mirror line. 7 to the mirror line. 7 on the other side. So it goes down to -7 down here. Good. Then this point over here now, as I was saying, this point, it is what? 6 to the mirror line. So it's going to go down to -6 below the mirror line to here. So that is coming to this point right here. Another one is going to just be right across from it over here. This point. So your image of that is supposed to look like this. And that is your P double prime. That is it. You just need to draw these things with a ruler, right? Don't draw them with a friend like me. Draw them with your ruler. But I go to that. All right. Let me take this out now. Then we have to go describe these transformations now. Because remember, we had a transformation from this to this, which is clearly an enlargement. I have a transformation from this to this one, which is a rotation. The problem is finding the center of this rotation, because most times when they give you a rotation, the center of the rotation is the origin, but they change it this time. So I'm going to show you how you find the center of the rotation when it's not the origin. I did it in the class when I was teaching the topic now, but it is so rarely set. Most people don't remember it. Even a lot of teachers don't remember it because it don't set often. All right, it was an old traditional way to do it. All right, let's go. So you have to remember this, guys, just in case I set it again. Just in case I set it again, you have to remember this was last year they set this. Question said, describe fully the single. So they put the word single in bold letters. So you can't do no combined transformation, a single transformation that maps P onto Q first. Which transformation map P to Q? Let's look at it. So this is the Q1. So from this one to this one, clearly it's an enlargement. You have to remember now that enlargement has two components. It has a scale factor and it has a center. In describing that enlargement, you have to state those two things. So we can decide what the scale factor is first by just looking at a side, the change in dimensions of a side. So take this diagonal piece here, for example, across here. That was 2 units across. And if you look at the image, it is now 6 units across. 1, 2, 3, 4, 5, 6. So it has gone from 3 units across to 6 units across. From 2 units across to 6 units across. That's a scale factor of 3. So you know the scale factor is 3 because the thing has been tripled in size. So first you know the scale factor is 3. It's also a positive 3. How is a positive 3? Because the image and the object point in the same direction. So for example, here you're pointing down on the object, and here this is also pointing down on the object. So you know that the scale factor is a positive 3. If they were pointing in opposite direction, then the scale factor will be a -3. So we know the scale factor. The next thing we need to find is the center of the enlargement. So to find the center of the enlargement, remember, you're going to join corresponding points and extend them back until they meet. So for example, these are 2 convenient corresponding points to use. All right, so I'm going to join those 2 first. When I join those 2 and extend it back, I know that the center of my enlargement is on this red line. Then I'm going to join this point and this point and extend it back as well, because these are 2 corresponding points. So I just join them with the ruler and extend it back. It looks as if the center of my enlargement is this point. But I have to test and make sure it is correct, because remember, the scale factor of 3 also affects the distance from the center. So for example, this point right here, right now it is 3 units from this center point that I've marked. If this is the correct center point, then the image is going to be 3 times 3, 9 units from the center point. This is a corresponding point to this. Let's test it. 3 here, so 3 more makes 6, 3 more makes 9. See that? So the distance has been tripled from this point. So it is true that this point is the center of the enlargement. All right. So now that I have that point as the center of my enlargement, I can give my description. What's coordinate of that point? That point is -10. See there? -10 is the x value, and the y value there is 7. -10, 7. So I'm now ready to describe it. -10, 7 is the center, and the scale factor is 3. So let's describe it now. So I can describe it as an enlargement. See there? It is mapped onto Q by an enlargement of scale factor you can put k equals 3 if you want. I can just put 3, scale factor 3, and center we said it was -10, 7. That's the center of the enlargement right here. That's what they're looking for if you describe an enlargement. You'll be looking for the scale factor and the center and the name of the enlargement, name of the transformation. So in describe an enlargement, you have to give those two things. You have to give the scale factor and you have to state the center of the enlargement. If you don't put those things, you're going to lose marks. But go to that one. Nobody got that one? All right, beautiful, beautiful. So this last one now is a special one that you have to remember, because I'm telling you, they don't set this very often. What transformation take it from this one to this one? A lot of people couldn't figure it out. All right? It's actually a rotation, and it's a 90-degree rotation. The problem is, how do you find the center? Touch a youngster bit for me now. I bet one of these companies. Huh? You ready? All right. You have a method that you use. Where you get your center point? What did you get for your center? All right. 4,2. -4,2 you get right there, so? Let me see if that makes sense. That to this. Yeah, look right, you know. Look right. Look right. Look right. He's saying it's -4,2. Here to there. Like 90 degree for true. And then up here to down here. Yep. Look like you're right. But let me show you the method. All right. If you have a different method, you can tell us, right? But I'm going to tell you the traditional method to do it. All right, let's go. Boom, bang, boom, bang. Right. So I want to show that this now. I want to describe that transformation. So the first thing you realize that it turned. So you can look, for example, and say, okay, from this point to down, this pointing down here was pointing down this way. And that side now, that line now is now pointing this way. Remember, the transformation is from this one to this one, you know. So it's like the rotation. If you take the tail, for example, it's like the rotation go this way, turn around that way, 90 degrees, right? If you look at the tail here, wait, gone to, it's like the arrow turn around this way, turn around. All right, turn 90 degrees clockwise, because it's like a turn up so. Anti-clockwise, yeah, this way. I can look and say, okay, this arrow is now facing south. So let the arrow turn up this way to be like this now. So it's an anti-clockwise rotation of 90 degrees. Also, I will say 90 degrees because this was vertical and this is now horizontal. So it's a 90-degree turn. So it's an anti-clockwise 90-degree rotation. So we know that. So we know it says that 90-degree rotation, we know the angle, and we know the direction. The next thing we need to know is the center. So let me tell you where you can find the center now, guys. What you have to remember. The center of a rotation is on the point of intersection of two perpendicular bisectors. of the lines joining corresponding points. That's a traditional method. So what you do, you join corresponding points and you do the perpendicular bisector of those corresponding points. And where those two perpendicular bisectors meet, that is the center of the rotation. Watch this now. So you're going to find some convenient points. You have to know the points that are corresponding to each other. So like this one and this one correspond to each other. Right? And this one up here is this one. So that corresponding. And this one corresponds to this one. Now I like those two as corresponding points because they are on this vertical line. So it's easy for me to find the perpendicular bisector of that vertical line, connecting those two corresponding points. So I want a line that is perpendicular to that line and pass through the midpoint, perpendicular bisector. Now, how long is that line? 1, 2, 3, 4, 5, 6, 7, 8. Good. It's another thing. It's good. So I can divide it half and half, 4, 4. So 1, 2, 3, 4. It means that my perpendicular bisector of this line is here. So my center point is on this line, this red line. That red line is a perpendicular bisector of that blue line. So my center point is on that red line. That's the first one. Then I need two more. I need another pair. So let me think about this blue now. So I know that my center is on that line. I need to do another two, right? So let's say I'm going to work this point and this point. Let's try these 2 points. I want to find the center, the perpendicular bisector of this blue line as well. All right. Now, how long is it? It is 1, 2, 3, 4, 5 down, 1 across. So if it's 5 down, 1 across, but I've got 2.5 down, half across. I don't want to use that one. Let's try see if we can find another pair where the numbers are easier. Just as though this one was 8, easy to cut half and half. That's what you want. All right. So let's find another pair. So let's try this one, which corresponds to this one. All right? Because remember, this point corresponds to that point. So if we come around by the shape, this one corresponds to that, right? So those two correspond to each other. This one, this point is this point. All right? Because if you rotate this up here, this is going to come up to the top where it is now. All right, good. So these 2 points correspond to each other. If you're not sure, put letters around it. So those 2 points correspond. Let's test this one now. So this line now. I want to find the perpendicular bisector of this line joining these 2 points. The perpendicular bisector. What are the dimensions on that one? Let's count it off in purple. It is 1, 2, 3, 4, 5, 6 down and 2 back. Easy numbers to work with. 6 down, 2 back. So the halfway point is going to be 3 down, 1 back. So the halfway point is going to be right here. 3 down, 1, 2, 3 down, 1 back. So right here is the midpoint of that blue line. You can maybe look at it and see it, that this is the midpoint of that blue line right there. So I know I want the perpendicular of that line. Now you can put your protractor on it, and get a perpendicular now. But if you draw a perpendicular now on this line, like so, it's going to pass through here. So those are my 2 perpendicular bisectors. See, the 2 of them meet at this point right here. So that is the center of my enlargement. The 2 perpendicular bisectors meet. Let me draw the original one. The original line that I used was this line here. That went all the way down to the bottom. Let me draw it in purple. The original line was this line that went all the way down to the bottom here. But these 2 points were corresponding points. This one and this one. This is the perpendicular bisector for those 2. For that line, that purple line. And then the blue line here, this other line is the perpendicular bisector for it. How I get the perpendicular bisector for it? Find the midpoint. I can, since you just want to do it quickly, put the protractor on it and mark where the 90 degree is. Understand? So you put the protractor on it. Let me draw the protractor and show you in green. Or the position of the protractor in green. So you put the protractor on this line, for example, right? And it is like this. That's a protractor. And you mark the 90 up here. This up here is the 90 degrees. And you mark that and you get that line where that 90 degrees is. You understand me? So you could do it that way with the protractor to get the 90 degrees. But you want the perpendicular. So you find the midpoint first and then you draw the perpendicular from the midpoint. That's a perpendicular bisector. Where those two perpendicular bisectors meet is the center of the enlargement. So that blue point is the center of the rotation, sorry. Is the center of the rotation. So you can test it now to make sure it is correct, because if this is the center of the rotation, remember that this point was rotated to this point, So you can go like this. And join them. And calculator will select this angle is 90 degrees, and the rotation would be like this. Rotation is like that. See that? You can test another point if you want. And this length is the same, sorry. This length and this length is the same. You can see it. Those two lengths are the same. You can test another point if you want. So for example, you can test this point with this point. Those are corresponding points. So if you draw a line out to it, and draw a line out to this one, you can literally see that this angle here is a 90-degree angle. So the rotation is this, from here to rotate down to there, 90 degrees. So you're confirming that that is the center of your rotation, this point, which is 4-2. This point is 4-2. So Athena, you see I have a different way to do it? Come and see how you do it. You have to learn. 4-2. So let me describe it first and then come show me the other way that you have. Huh? Come show me how you draw the art them. Come show me. Come and show me. Come on. I want to see you get the 4-2 bars. I want to see. Come. So I want to say Q to R is a anti-clockwise 90 rotation about the origin. And because I don't know another way, that's why I want to see it. An anti-clockwise 90-degree rotation about, not the origin, about the point. It's an anti-clockwise 90-degree rotation about the point. What is it again? Negative 4-2, right? Negative 4-2. About the point, negative 4-2. Come on. Come on, show me the way that you have. More maths equals better maths. Come. Huh? Multiple choice? Somebody have it? Come do this first. We do that afterwards. Come. Come now, come now, come now. Come show me the man. Come. More maths equals better maths. Show me. Let me take this off. Show me how you did. Show me. Put this pen on it. Yeah, use this and mark it and show me. Come on. Never too old to learn, man. Show me. What you do?
And set life around us and carry it way around and switch out all of them meat, sir. That's all I did.
What you do? Come on, Mr. Edo. Turn on that, Mr. Edo. We have to learn, guys. We have to learn. If there's another way to do it, I want to see it. It's put easier than this way. You're trying to do the mathematics the easy way.
All I did was I looked at the 2 points and then I swing the arc up.
But where you put the center? Where you put the center to swing the arc? That's
right, I put it right here.
So you can attest points.
Yes, sir. When I got that point.
Oh, you can attest points. You can attest points and see which one makes sense. Oh, all right. It's a trial and error thing him do. Him do a trial and error thing. Okay, you can do that too. You can look and see relative where the values are, and just kind of test them until you find the right one, But I'm showing you a specific way to do it, which is to join 2 points, corresponding points, get the perpendicular bisector of that one, join another 2 corresponding points, draw the perpendicular bisector of that one where the 2 perpendicular bisectors meet, That is the center. That is the traditional way I know how to do it from when I was in school. All right? So let's learn that way and make sure that you have it. You go do it? All right, but online okay with that method? Just want to make sure. It's very important because we don't know what's coming on the exam paper again. But online okay? Elizabeth? Elizabeth? Merchant? I don't hear me. You hear me?
Yes, sir.
Yes, sir.
All right. You need to pay attention to that method that we just did, right? But just in case I set one again, we don't know what's coming on the exam. Anyway, quiet now, let's go. Next question. So that question finish. All right. So we'll just reach number 4. So let's pick up the speed now. Wanted to spend some time on that one because it's not a popular question. I've not set one like that in the past, maybe 20 odd years. I'm telling you. All right. Let's go. It says lines L and M are drawn on the grid below. I like this question because you can look at the diagram and figure out your gradient and figure out your y-axis intercept by just looking at the graph. It says write down the coordinates of the x-axis intercept of L. And they said coordinates. You have to give the x and the y value. So this question is asking you for this point right here, x-axis intercept. That point is 6, 0. All right? So this point is 6, 0. Next one wants the y-axis intercept of M. So this one is asking you for where M intersect the y-axis, which is this point right here. That's where line M intersects the x-axis. That point is 0, -2. You put the x value first. It is 0, -2. All right, let's continue. Next question says, the line L has this equation. Find the value of K, given that 9K is on the line L. Now let's see if we can see it on the graph first, because this is where the x value is 9. You know. I want to do it 2 ways, right? Let's see if we can see it on the graph. So the x value is 9. See it here, line L. So line L here, where x equals 9 is right here. This y value looks like -1.5, -3/2. So it looks like this point is 9, -3/2. So the graph is telling me that that is -3/2, -1.5. Right? That's what it's looking like to me. I'm going to check it with the equation now. So I would say the K is -3/2 or -1.5. But you can do it also by plugging the values into the equation. Good? Because those points, that point is on the equation, it's on the line, and so it satisfies the equation of the line. Little girl, you need to say you have to go outside. You know, pay attention. None at all. You know? Pay attention, man, and stop talking. Ready? So I want to take this point and substitute it into the equation because the point is on the line. So it satisfies the equation of the line. All right? So where the x is, I'm going to put 9 plus 2 times the y is k. So it becomes 2k minus 6 equals 0. And I'm now solving for the k. So this 9 minus 6 is 3. So it becomes 2k plus 3 equals 0. You can see it. K over the 3 and divide under the 2. You're going to get the k equals -3/2. So I was correct. So the graph showed it as well. So the k is -3/2. Easy like that. Everything is consistent. Next question says, find the equation of line M in this form. So to find the equation of line M, we need the y-axis intercept and the gradient. Let's look at line M. So line M was this one. We already have the y-axis intercept right here. It is C equal -2 for line M. Then for line M, we need a gradient. It's a positive gradient. So all we need to do is choose up 2 points and count the rise over the run between those 2 points. I'm using this point and this point, for example. Any 2 points you can use. So to go from this point to this point, always go from left to right along the line. I have to rise 2 units. See there? Rise 2 units and run 1 unit. Run 1 unit. That gives you the gradient. So the gradient M is rise 2 over run 1 over run 1. So the gradient is 2 over 1, which is 1. Is 2, sorry. 2 over 1 is 2. So the gradient is 2, and the y-axis intercept is negative 2. So let's do it down here. So for this line M, see it here? The gradient we worked out as 2 over 1, which is 2, and the C is negative 2. Therefore, the equation is simply y equals the M is 2, so you get 2x, and the C is negative 2 minus 2. That is it. Easy like that. No calculation needed. Just count off what you want from the graph. Next one says, show by calculation that line L and line M are perpendicular. So when lines are perpendicular, the product of their gradients is negative 1. The product of their gradients is negative 1. This up here is the gradient of line M. So we can write that. This is M. So I'm going to put like a small m on it. We need to know the gradient of line L now, right? So the gradient of line M, we have it already. It is equal to 2. Let's do the gradient of line L now. The gradient of line L, and see what it is. I'll count it off on the graph. The gradient of line L. So if we go back up to the graph, I'll go on to line L. Let's count out this gradient now in purple. So we choose any 2 points. So we can choose these 2 points, for example, here and here. Remember, go from left to right along the line and check the rise and check the run. So we're going to rise 1 down. That's a negative 1. So the rise is negative 1 because you have to go down. They got 2 units to the right. That's a positive 2 run. Positive 2 run. So the gradient of L is rise negative 1 over run 2. So the gradient of line L becomes minus a half. This here was the gradient of line M. Put M on it. So it's negative a half. So we're going to come down here now and put that the gradient of line L is actually negative a half. So we multiply them now. The gradient of line N times the gradient of line L. You multiply 2 times negative a half. It becomes negative 1. And this means that they are perpendicular when the product of the gradients is negative 1. Therefore, L and M are perpendicular. That's what CSEC wants to see, that they multiply the gradients and they equal negative 1. That's it. Next part says, line M and line L and line M represent the graph of a pair of simultaneous equations. Remember, simultaneous equations is used to find where 2 lines meet or two curves meet. In this case, it's 2 lines. When you want to find the point of intersection of 2 lines, you solve the equation simultaneously. If you want to find the point of intersection of a line and a curve, you solve the equations simultaneously. So simultaneous equations is about finding points where the curves meet or where the lines meet. So this question is really asking us to write down a solution for the pair of simultaneous equation, which is the coordinate of the point where they meet. And just write down, no calculation needed. You can go on the graph and look where they meet and just write the coordinates. So you go on the graph, look where the 2 lines intersect each other, which is right here. Let's mark it in red. This point is 2, 2. 2, 2. So they meet at the point 2, 2. So you don't have to actually calculate it. This is there clearly on the graph where they meet. 2, 2. So you can come down here now and just write 2, 2. So they meet at the point 2, 2. You all got that? Students, you got that? Anybody got that? I'm so confident, you know. Don't forget them 1 mark, then them easy. Simultaneous equations about points where the curves meet or where lines meet. That's what you do when you find when you solve simultaneous equations, you know. You're finding the point where the lines meet on a graph. That's what you do. Anyway, let's continue. So you're still learning. Number 5. The cumulative frequency curve below shows information about the time taken by 200 students to solve a math Olympiad problem. All right, so there are 200 students and this is time taken. So remember, the students down here, they took the shortest time. And the students at the top, they took the longest time to solve it. All right? Good. So assuming that the ones that took the shortest time are the brighter ones, then the brighter ones are down here. And the ones who are not so bright, because they took so long to do it, are the ones at the top. All right? So let's continue. It says, using the cumulative frequency curve above, find an estimate for the number of students who took more than 50 minutes. Now remember, a cumulative frequency graph, like this one, for example, is meant to show how many students took less than or equal to a given time. So if you want to know how many students took less than or equal to 20 minutes, you come up on the graph and you read it across here. That's what it shows. All right. Sometimes they also show how many persons took less than, but most times recently I find that the graph are less than or equal to graph. So I'm going to put it here. Less than or equal to time. That's what it will show. I've realized in recent time when I give one of these cumulative frequency graph, it is showing less than or equal to data. So it's going to show you how many students took less than or equal to any given time. All right? So this one's how many persons took more than 50 minutes. So what we have to do is go on the graph, see how many students took less than or equal to 50 minutes, and the rest of them took more. Because the graph is going to show you how many took less than or equal to 50 minutes. But the question is asking how many took more. So you're going to take the difference. So look for the 50, see the 50 here. Come up on the graph at 50, up on this line. Let's use the red. This is the 50 line. That's a 50 minutes line. Come up here and read it across here. Now you have to be careful now with the scale of the graph. You always check the scale of the graph. So look at the graph down here, so use down here to check it. So you can know what each of these little lines represent, right? So there are 20 students in an interval of 5 lines, 5 of these lines. So 20 divided by 5 lines give me 4. So it means that each of these little lines is 4. So this is like 4, 8, 12, 16, 20. You can see it. So each of those little lines is 4. All right, let's go back up here now. So this mark, therefore, that we have gotten to is actually 4 below the 20, which is 196. This is 196. That's what this mark is. So 196 took less than 50 minutes. But the question is asking for how many took more. So it means that the 4 up here, so, took more. You understand? Because the graph showing you how many took less. So it's 4 took more. Because the ones who took more than 50 minutes are up here, so. Which corresponds to this part of the graph at the top. Which corresponds to the few students up in here, so. The 4 students at the top. So it's basically 200 minus 196. So the answer for this is 200 minus 196, which is 4. The 4 at the top. 200 minus 196. 4 students took more than. You get what? That's wrong. 195 wrong. Can't be 195. Because see there, look at the graph. Where you get the 5? See there, the graph come right up to meet this line right here, so. See there, right it meet the graph right here, so. Right at that point. Huh? Anyway, all right. So that is it. 194, 196 is 4 above. Next question says, the median time taken. So remember, the median time is the time taken by the student halfway of the 200 students. So it's time taken by the 100 student. So you find the position of the median is a 100 student right here. So this student is in the median position. That is the position of the Q2 right here. So you're going to come across on a graph and see what time that student took. That is the median time. So you come across on a graph for 100 to here. I can zoom, so I'm going to zoom it up. It's right in between here, so. Right in between there. Use your ruler and draw this line down. Then we have to go now and read the horizontal scale and make sure. Horizontal scale is easy because there are 10 lines up to 10 minutes. So each of those little lines is a minute, right? Each of those little lines is a minute. So this is 30, 31, 32, 33. This is 34. So this is actually 33.5 minutes. 33.5 minutes is the median. All right, 33.5 minutes is the median. So let's mark it. This is 33.5. That is our Q2 mark. 33.5. So the answer right here is 33.5 minutes. Q2 is the median. It is 33.5 minutes. Is the median time. Next question. Huh? Is that estimate, you know, that we give it a marks? Probably they will give it a marks, right? Because they're estimating. See that? Well, let us try and get the precise answer, guys. Yeah? You got 33? All right. All right. So 33 is good. Next question says, the probability that a student chosen at random took at most 28 minutes. Now, at most really means less than or equal to 28 minutes. And you want the probability of getting one of those. So you want to know how many students took less than or equal to 28 minutes, and then divide by 200, because you're trying to get the probability. So how many students took less than or equal to 28? The graph is going to show you that, because that's what the graph shows. How many students took less than or equal to any time? At most 28 means 28 or less. At most 28 means 28 or less. So I'm going to say how many students took less than or equal to 28. Let's go on the graph again. So 28 is right here. 28 is right here. 2 before the 30, because every line is 1. So you come on the graph, it's coming right up to here. You can see it. It's an exact number that you can read off from the graph. And to make it nice for you, it's right here. That is 64, as one line above the 60, that's 64. So 64 out of 200. Probability that I want to know. 64 out of 200. So the probability is 64 out of 200, which becomes 32 out of 100, which becomes, that becomes what? Divide that by what? 4. 8 over what? 8 out of 25. All right, good. That's it. That's the probability of getting a student who took at most, because there were 64 students. Next question says, using the cumulative frequency curve on page 13, complete the table below. So they want us to fill in these values. All right? So basically, we're trying to get the frequency values from the table first, so we can multiply up and get this one. So we're talking, man. So we want to know how many students. So up to 10, less than or equal to 10, there were 12 students. So we want to know how many students get less than or equal to 20. And then now, between the 10 and the 20 is going to be the number of students here. All right? So let's look at the graph. So we need to see how many people get less than or equal to 20. And then between the 10 and the 20 is going to be the number of students here. So let's look at it. So you can look and see it. So the 10, less than or equal to 10 right here. Come up on the graph, you see it matches 12. That is 12. So it's 12 students up to 10. That's what the graph just showed us. Up to 10, you have 12 students. So we're going to see what 20 goes up to. It's 20 here now. Up to 20. It's not equal to 20. If you zoom it up, it's right in between here. So I would say that is 20, 20, 24, 28, 32, 32 and 2 make 40. This is like, no, 32 and 2 make 34. That looks like 34 to me. Yeah. Because this is 32. Let's go again. This is 20, right? This is 24, 28. This is 32. And this is 36. So in between them is 34. So that mark is 34. So between the 10 and the 20, there are, subtract them, there are 22 students. So the value down here is 22 right here. This is 22. 22. So that, because the 12 plus the 22 give you the 34. That's why let's say I got the 20 is 34 on the cumulative frequency graph. And then we can figure out this last one, you know. Because remember the total frequency is 200. So we can do to get this one is add up everything that you have and subtract from 200. And then we're going to double check it on the graph. Let's do that and then double check it on the graph. So I'm going to do 200 minus everything here that we have so far. And then double check it on the graph. So it's 200 minus this and this is 32, we know. That's 34, sorry. So it's minus 34 at the top. We're going to minus this 42 right here. We're going to minus this 84, and this 4 make 88. So we're going to subtract 88. So this is 36. So we're saying this is supposed to be 36. But we can check if between 40 and 50 is 36. Really in this group, you know, which is really between the 40 mark and the 50 mark, we are saying that there are 36 students. Let's check it. Between the 40 and the 50, between the 40 and the 50, there are 36 students. So let's check that. Just make sure if we get 36 for real. All right, let's look. Between 40 and 50. All right. So we know that 50, we already know what 50 was, you know. 50 corresponded to 196. We need to know see what 40 corresponded to. So if we go 40 up here, it's 40 here, so a nice value to, you know, see there 40. So 40 corresponded to 160 students. See it? 160. So the difference here is between 160 and 196 is 36 students for real. So we can accept that value that we have down here is 36. So I've completed the table correctly, it's 36. So now this to multiply these across. Multiply these two values, the midpoint times the time. Yes? How much? This is 341 exactly. 341 and down here, so you get that one as well. Yeah, 1638. Good. So then now to get the mean, you have to add up everything right here. I get the sum of everything. So this is the sum of the frequency, the total number of students, add up everything right here now. So it is 66 plus 341 plus 1071 plus 2982 plus 1638 plus 222. That's 6320. That is the sum of the frequency, sum of all the students, sum of the sum. It says use the information to complete the table above to estimate, to calculate an estimate of the average time taken by that's mean, right? So the average time, which is really the mean they're asking us for, is equal to the sum of the sum column, sum of fx. Remember, this column is your sum column. If it's to sum the values. sum the time by all the students. It's an estimate. Divided by the number of students, which is 200. So basically dividing this by this. So it's 6320. That's the total time by all the students divided by the 200 students, which works out to be what? 6320 divided by 200. Yeah. 31.6 is what? Minutes? You have to say minutes in it. You can just put the value alone in it. You have to say minutes. Yes, minutes. 31.6 minutes. That is it. 31.6 minutes. All right, next question. This question says, we have to use pi as 22 over 7. So now we're going to be doing some circular measures, right? It says, the diagram below shows a scaled drawing, of a running track. It consists of a rectangle and two semicircles. So you have a semicircle over here and over there. So together they make a circle, right? Together these make a circle. Just be mindful of that. All right? It says the diameters LN and MP. So these are the diameters. So based on that, we know the radius is half of that. And each of them is 49 meters. So let's make a note. The radius is half of 49. So the radius is 49 over 2. 49 over 2 is how much? What is that? 28.5? 24.5? So make a note. Our radius that we're working with is 24.5 meters. Why am I doing that? Because remember, circular measures, we tend to be working with radius, not with diameter. All right, so that's why I'm doing that. So anyway, and it says that the length here so is 98 meters. Show that the total length of the running track is 250 meters. So the total length of the running track, guys, is going to be these two long sides, which is 2 times 98, plus this whole thing, this arc and this arc, each basically make a circle, right? Circumference of circle, which is 2 pi r. So it basically becomes equal to, total length is equal to 2 times 98 plus the circumference of a circle is 2 pi r, and the r is 24.5. 24.5. This right here says 2 pi r. This is actually 2 pi r circumference. When you add up all of that, you're supposed to get the answer that they gave us. Remember that this pi is 22 over 7, right? So I'm putting the calculator as 22 over 7. So it's going to be 2 times 98 plus 2 times a fraction 22 over 7 times 24.5. See? 350 flat. 250 meters. That's it. Remember the pi is 22 over 7. That's it. All right? Next question. That was shown. It says, Nathan walks at a constant rate of 1.4 meters per second. This is not complicated, guys. All this means is that in 1 second, he walks 1.4 meters. I'll just write 1.4 meters in 1 second. That's all it means. 1.4 meters in 1 second. So in 2 seconds, it's going to be 2.8 meters multiplied by 2. In 3 seconds, you multiply by 3, right? Simple. It says, calculate the time it will take him to walk 7 laps around the track. Remember, each lap is 250 meters, you know. So if it's going at this speed and you want to know the time, you have to divide the total distance that he's walking by the speed that he's walking at, right? So you want to know how long it's going to, in other words, you want to know how much of this 1.5 meters is in the total distance that he's walking. So the time that he's going to take, see here, the time that he's going to take is going to be 7 times 250 meters. That's the total distance he's walking. He's walking at a rate at 1.4 every meter. Every second he walks 1.4. So you want to know how many 1.4 meters is in this distance. And that gives you the time. Right? So it is 7 times 350. I divide that by 1.4 and get 1,750 seconds. 1,750 seconds. All right, that is the time that he took. 1,750 seconds. Next one says, Tafari runs 1 lap in 68 seconds. So now he's running. This person was walking. Now this one is running. So he runs 1 lap in 68 seconds. Remember, 1 lap is 350 meters now. Determine the number of laps Tafari can complete in 1 hour. Determine the number of laps he can complete in 1 hour. So what we need to know, what we need to do, since he runs 1 lap in 68 seconds, we need to find out how many 68 seconds are in 1 hour. So we can convert the 1 hour to seconds and divide it by 68. Everybody understand that? We need to know how many 68 seconds are in 1 hour. Because for every 68 seconds, he's running a lap. So we need to know how many 68 seconds are in 1 hour. So the number of laps, see here, number of laps is going to be 1 hour time, 1 hour divided by 68 seconds. We have to convert 1 hour to seconds now, right? So they have the same unit, right? So the 1 hour is 60 minutes, and the 60 minutes, if we divide that by 68 seconds, right? Times 60 seconds, that's the amount of seconds in 1 hour. Divide that by 68. That's going to give you the answer. 60 times 60 divided by 68. So you convert the 1 hour to seconds, it is this. First, it is 60 minutes, and then 60 minutes is 60 seconds. I multiply them. So it becomes a fraction 60 times 60 divided by 68. So it says how many laps he will complete. How many laps he will complete? I'm around 52.9 laps, you know. But I'm asking how many he will complete. He will complete 52. See that? So he's going to run 52.9 laps. How many he will complete? He will complete 52. How many? Determine the number of laps he can complete. So you're going to put it down here. Completes 52 laps. He's not quite finished reaching 53rd lap yet. So he completes 52 laps. Answer the question. Never ask for the exact. Never ask for the fraction of a lap. How many laps you will complete? 52. You get me? So that is it. All right. Next question says, Nathan completes running 1 lap. So Nathan knows going to run, right? Nathan completes running 1 lap of the track every 72 seconds. So remember, this person up here now is running it in 68 seconds. This person is running it in 72 seconds. That 4 seconds more is taken, right? 4 seconds more is taken. Tafari and Nathan start running at the same time from a point L on the track. So point L on the track, it really matter where it is still. So this is point L, like the starting line of a running track, right? And 2 of them start running at the same time, but one running in 68 seconds. So he's going faster, right? That's completing 1 lap in less time. That is Tafari. Other person running it in 72 seconds. So he's taking 4 seconds more to run a lap, right? 4 seconds more is taking per lap. All right. It says, each completed a number of laps on the track. Calculate the least number of laps that each will complete before they are both at L again. In other words, when they are both at L again, it means that one of them run 1 lap more than the other one. But understand that? And the beauty about this 4-lap difference is that the 4 is a multiple of 72 and also a multiple of 68. No, a factor. 68 is a multiple of 4 and 72 is also a multiple of 4. The 4 difference between them. So let me see how you can reason this out now. First, which one of them are going to run more laps? Tafari or Nathan? Tafari completes 1 lap in 68 seconds. Nathan completes 1 lap in 72 seconds. And the two of them running. Which one of them going to finish? Which one of them going to run more laps? Can't be Nathan. Nathan going slower. Nathan is completing 1 lap in 72 seconds. He's going slower. Tafari is finished running a lap in 68 seconds. He's going faster. So he's going to run more laps. So when they meet again, he's going to be running 1 lap more. But understand that? So Tafari will do more. So we know that first. Tafari will do more laps. Let's put that down. And Nathan will be less. All right, let's talk. We can reason it out now. What is now? So listen now, they're doing a difference of 4 seconds, right? Every lap, they're doing a difference of 4 seconds. In order for them to meet again, it's that 4 seconds, it has to be added up every lap until it reaches 68, the time that Tafari is taking to complete a lap. You understand that? Or the 4 seconds difference must also add up to the total 72 seconds that the other person is taking to run a lap. Let me say it again. Every lap, one person does 4 seconds faster than the next person. The other person does 4 seconds less. So in order for them to meet back at the same point, it means that the number of laps done has to be a multiple of 4. So you have to count how many 4 seconds when add up to 68, or how many 4 seconds when add up to 72. That's what it is. Because every lap there's a 4 seconds difference between them. So after the first lap, one person is 4 seconds behind. After the second lap, he's now 8 seconds behind. After the third lap, he's now 12 seconds behind. After the fourth lap, he's now 16 seconds behind. So you're gonna add and count how many 4 seconds are there in 68 seconds. Because after 68 seconds, basically they would equate to 1 lap of the person who is in 68 seconds. So see it here, number of laps. So it's gonna be 4 times the number of laps must be equal to 68 for one of the persons, and 4 times the number of laps for the other person will have to be equal to 72. The person is going faster. The person is going faster, right? His thought is he has to do a number of laps that add up to 72. The person is going slower. He has to do a number of laps that add up to 68. So if you divide by the 4, you're going to get number of laps equals 68 over 4, which is how much? 68 divided by 4. That is 17. So after 17 laps, this person would have 17 laps, would have accounted for 68 seconds, yes? All right, I'm soon deal with that. And then here now, we're going to divide by the 72, you divide by the 4 as well. That paper not going to be relevant again. You know? So 72 divided by 4, 18. So this person do 18 laps, and this person do 17 laps. That is it. So this person do 18 laps, this person do 17 laps. Think you understand it, guys? Think you understand it? Simply, you know, remember, you know, they are doing a 4 laps difference. Right? 4 laps difference every second. So in order to make up that time, right, you want to know how many laps will account for that 68 seconds on a lap that one of the persons doing. It's 17 laps, because 17 times 4 give you the 68. and this person is doing 1 lap less. This person is doing less because he's going slower. Tafara is going faster, so he's going to be doing 18 laps. At the same time, Nathan would have done only 17 laps. He's going slower. That's one way it can be worked out. Can show you another way to work it out. You know? I see another way to work it out. I'm thinking of another way to work it out. To me, that's a logical way to work it out. Every lap is a 4 seconds difference. You want to know how many laps times 4 equals 68. And how many laps times 4 equals 72. You understand? That's what it is. Because you want the two of them know the time to match up. How many laps where the difference is 68. And how many laps where the difference is 72. So 17 laps times 4 would make 68 seconds. So this person, after he completes 17 laps, he would have been 4 seconds behind 17 times. 17 times 4 is 68 seconds, which is a full lap now that this person would have done. Tafari would have done in 68 seconds. And then it goes the other way for the other person. So when Tafari completes 18 laps, Nathan is just completing 17 laps. All right? Let me see if we can show another way. Maybe another way you can understand it better. Let's show another way down here. Make it smaller and show another way. My brain is thinking of another way to do it. All right. Let's think of another way. All right. Watch this now. Let's show you another way. Let me show you another way. So when they reach back the same point, right? They would have been running for the same time, don't it? Don't it? They would have been running for the same time. When they reach back the same, they start at the same time, and they start at the same time, you know, and they're going to reach back L at the same time again, at the same point. When they reach back, both of them would have been running for the same length of time, total. The total time run by Tafari, is Tafari name? The total time run by Tafari will be equal to the total time run by Nathan when they meet again, right? The total time run by Tafari, remember, you know, he's running 68 seconds every lap. So it means that the number of laps done by Tafari times 68 is going to be equal to the number of laps done by Nathan times 72. But can I appreciate that? Right? And the difference in the lap between the two of them is just 1. Tafari is doing 1 lap more than Nathan. Right? Because he's going faster. So if we simplify this equation down, divide it by 4 and divide it by 4, you're going to get 17 times t. 17 times t equals 18 times n. Now look here now. I have 18. Let me leave those. Now look here. For these two things to be equal, guys, this is going to have to be equal to 18. And this is going to have to be equal to 17. Can you see that? For these two things to be equal, for this to be equal to this is going to have to be equal to, remember that there's a 1 difference between them. Or 1 do 1 lap more than next when they meet again, right? So this is going to have to be 18. And this is going to have to be 17 for them to be equal. So you see, Nathan would have done 17 laps, and Tafari would have done 18 laps. That's another way that it could be worked out. In order for those two things to be equal, I don't want to worry about everything. In order for these two equations, in order for this equation to be equal, this will have to be equal to the value there, 18. And this will have to be equal to that value there, 17. Because we know that there's a 1 difference between them. And that is it. So you know, so Nathan is doing 17 laps, Tafari is doing 18 laps. That's another way you could look at it and do it. Using the total time. The total time run by Tafari, total time run by Nathan is the same. So the number of laps run by Tafari times 68, that's his total time. Guys, run his number of laps times 68. And then Nathan's number of laps times his time is his total time that he runs. Nathan's total number of laps times 72 is his total time. The total time for both of them is the same. So we equate this total time and simplify it down. What makes it work? Because this 17 is a prime number. 17 is a prime number. Right? So if 17 times a number equals a number times something else, then this have to be 17 across here because 17 is a prime number. You understand? That's what I'm saying? If 17 times a number equals another number times, then this number over here has to be 17 because 17 is a prime number. All right? That's what I'm thinking. That's what I'm thinking at this stage. I think that's a good enough way. I'm thinking of yet another way to do it. Thinking of yet another way to do it right now. More maths equals better maths. I'm thinking of yet another way to do it. Let me see if this other way will do it. Huh? No, you want to know the laps where them run. The laps I try to find out what laps them do. Let's do another way. Let's do it another way. I'm thinking of another way. We know, say, when they meet again, one run one lap more than the next. Right? One of them run one lap more than the next. Agreed? So, let's say we use Nathan's lap as a reference. Let's say we use Nathan's lap as a reference. So Tafari's laps times 68 is going to be have to equal to Nathan's laps times 72. Set up another way. Put in T for Tafari and for Nathan times 72. But we know that Tafari is going to run one lap more than Nathan because he's going faster. So you say Tafari's number of laps is equal to Nathan's number of laps plus 1. So I'm going to replace this T with N plus 1. Tafari's number of laps, I'm going to replace it with N plus 1. So N plus 1 times 68 will be equal to N times 72, which is just 72N. Doing it another way. And if we solve this equation for N, that is Nathan's lap. And then to get Tafari's lap, we just add 1. So if we solve this now for N, you're going to get 68N plus 68 equals 72N. If I solve this, carry this over here and subtract it, 72 minus 68, I'm going to get 4N equals 68, with the same equation we had before. You know? See, come back to the same equation. 4N equals 68. So if you divide this, you're going to get the N equals the same 17. You're going to get the N equals 17, which is Nathan's lap. That's another way to look at it. If you solve this right here, so now, you're going to get N equals 17. And Tafari do 1 lap more. So therefore, Tafari equals 17 plus 1. So Tafari's lap is 18. So that's 3 different ways to do it. 3 different ways to do it. I think I like the first way better over here. All right, put a different color. So that way, or this way, or that way. 3 different ways. All right. Tafari did more, Nathan did less. All right, that is it. So put the answers here. a different color. I like this question. I like it. So I spend so much time on it. This is 18 is the answer here. 17 is the answer here. All right, let's move on. I spent too much time on that one a while ago. Number 7. I'll finish this rest of these quickly. 7, 8, 9, 10. 3 more. 7, 8, 9, 10. 4 more. All right, let's finish this one quickly. So this one gives us the pattern. Look at it, 7 business here, so I got like a 7 thing shaded, right? At the shading on the 7s. See that? So the question said, the grid below shows the first 3 figures in a sequence. No, understand. No, stop talking. It's something like the class. Not like the class. It's much problem people in our class. The grid below shows the first 3 figures in a sequence. Each figure is made using a set of small squares of unit length that are both colored and shaded. So the colored ones are shaded and white unshaded. It says, in the space below, draw figure 4. All right. So let's look at it. There were 3 across the top, and then 4 across the top, and then 1, 2, 3, 4, 5 across the top. So now I need 6 across the top. So I'm going to put it here. 6 across the top. 1, 2, 3, 4, 5, 6. And then over the diagonal, I'm going to have 1, 2, 3, 4 down here. So when it is 1, 2, 3, 4, 5, it is 1, 2, 3, 4. So there's 5 down as well. So 4 across and 5 across and 5 down. Let's check it. 1, 2, 3, 4, 5 across. And then including this one in the corner, it is 1, 2, 3, 4, 5 down. Same thing here. 1, 2, 3, 4 across, including this, it is 1, 2, 3, 4 down. Okay. So I'm going to reach 1, 2, 3, 4, 5 across. I'm going 6 across. 1, 2, 3, 4, 5, 6 across, 6 down. 1, 2, 3, 4, 5, 6. That is it. So let me just shift this over. Maybe put it here. And then shade it up. Shade up all of this. And shade up down here. That is my shape, like a 7. All right, that's my figure number 4. This question says number of colored squares C and the total number of squares T. So the number of colored squares and the total, number of colored and the total. And the perimeter P follow a pattern. Study the pattern in the table below and answer the questions that follow. Let's look at it. I'd like to fill out this row here first. So this is going up by 2. So the formula has 2n in it. The first figure has 5. 2 times 1 is 2 plus 3 make 5. This one going up by what? 4. So that one going up by 4. So it has 4n in it in the formula. First figure is 12. 4 times 1 is 4. And you have to add 8 more to make 12. So it's 4n plus 8 is this formula. Over here, you know, the formula is a pattern. So first, these are the figure numbers. Here are the figure numbers. So the figure number first, which is n. Plus what? Plus what? It's always plus 2. So it's n plus 2. And then it is squared. So it's n plus 2 squared. That is it. N plus 2 squared. I don't have to write what it equal to. That's n plus 2 squared. All right? I need to fill out the rest of this now. So here is for figure 11. So I can take the 11 and drop it on the formula. I'm not going to try to figure it out. Drop it on the formula here. 2 times 11 is 22. 22 and 3 make 25. So this is 25. All right, this is worked out for us. Let's double check it. 4 times 11 is 44. 44 and 8 make 52. So that is good. Then I'm going to drop the 11 on this now. So it's going to become 11 plus 2 squared. That's 13 squared, which is 169. That figure is 169. Then for this one now, it is 2n equals 49. 2n plus 3, sorry, equals 49. So we can work out the n right here. So for this one, the 2n plus 3 is 49. Go over the 3 and subtract it. 2n is 46. Divide by it. It's 23. You can know right just now. This n is 23. This n is 23. You could have known it enough. 23. N equals 23. Then look over there first. This tells you the n value is 23 over here. Never need to work out anything. This is 23. And if you have 23, you can drop the 23 on this formula. 4 times 23 is how much? 4 times 23 plus 8. Drop the 23 on this formula. 4 times 23 plus 8. Let me get the calculator. Trying to work out for here. I'm going to drop the 23 on this formula. So it's 4 times 23 plus 8. I'm not going to do it any other way. 4 times 23 plus 8. That's 100 flat. 100 flat. So y'all got those figures, right? Y'all got those figures? Next one says, how many white squares are in figure 11? So figure 11 here. Easy. This is the total number of squares. These are the colored squares. So the white squares are the difference, right? So number of white squares. These are the total squares, right? And these are the colored ones. So the white ones must be the difference. So it's 169 minus 25. What do I work out to? 144. That is it. Question done. Now make up a little bit of time. Let's make up some more time with this now. Functions. This question gives us these 3 functions: f of x, g of x, h of x. All right. It says must find g of x minus 2. So we're going to put x minus 2 in the function here. So we're talking, Jesus Christ, and simplify. So it's going to become g of x minus 2 becomes equal to x minus 2 squared. Where the x is here, put x minus 2 squared and then minus 5. And so simplify. So I'm going to expand this out. It's going to become x squared minus twice the product of these two things is minus 4x. They're going to get a positive 4. Right? Square is going to get a positive 4. 4 minus 5 is negative 1. So it's going to become a negative 1. That's what they're going to get. All right, but that's how I'm going to get the 4x here, so. Because it's twice the product of these two things, right? That gives you the middle term when you expand a perfect square. F to the minus 1 of 11. Find f to the minus 1 of 11. We can find f to the minus 1 of x first and then plug in the 11. But you can also do this method. We can say, okay, we're going to put f to the minus 1 of 11 equals some number n. Let's do this method today. If f to the minus 1 of 11 equals n, then it means that 11 is equal to f of n. If f to the minus 1 of n of 11 equals some number n, then 11 is equal to f of n. So all we have to do now is put f of n equals 11 and solve for the n. When we find the n, we have the answer. So f of n would be this. Put n in this. So this now is going to give us 4n minus 1 equals the 11. And solving for the n. When you find any of the answer, so we'll put it equal n. So when you find any of the answer. So transpose the 1 first to get 12 and divide by the 4. So the n equals 12 over 4. The answer is 3. So if you find the inverse function first and then get the 3 same way, no problem. But the answer is 3. All right? Y'all got that? All right, next one. h of 1. This could have been h squared of 1. It would have been the same thing. If I give you this, it's the same thing. This means that we're going to put h of 1 first. h of 1. We're going to do the h of 1 in here first. Write that better. Working out this h of 1 here first, which means that we'll put 1 in the h function. H is just 3 to the x, so it becomes 3 to the 1, which is 3. So this becomes h of 3 to the 1, which means it is h of 3, because this is just 3. Then h of 3 now means that they put in 3 in the h function again. Remember, the h of x is 3 to the x now. That's what it is. This is going to become 3 cube now. But understand that? Okay, taking this 3, that is 3. Let me write it. This 3 to the 1 is just 3. So it's working out h of 3 now. And h of 3 now means they're going to put the 3 right here. So it becomes 3 to the 3rd power. 3 cubed. 3 cubed is 27. 3 cubed is 27. 3 times 3 times 3 is 27. So the answer is 27. Let's put this in red. All right. Next question. Next question says, function f is defined as this. It's a quadratic. It's a smile-shaped quadratic. All right? And I want us to complete the table below and plot the graph of the function on the grid. The scale is 2 centimeters to 1 unit. Use a scale of 2 centimeters to 1 unit on both axes. Remember, the values are symmetrical. I see a 0 here, and I see a 0 here. To the right of this 0 is a 4, so to the left of this 0 must be a 4 as well. To the left of this 0 is a -2, so to this side must be a -2 as well. That is it. The values are symmetrical. Those are the values. The values are symmetrical. We have to note that. The values are symmetrical. If you want to work it out, you can work it out still now and waste time. So for example, if I want to work out this one, I just put the 0 inside here. You see, I'm going to get the -2 just the same. That I just had a while ago, the -2. But I know it was -2 because the left of this 0 is -2. So the right of this 0 must be -2 because the values are symmetrical. And then to the right of this 0 is a 4. So the left of this 0 must be a 4. And the values are symmetrical outwards. And the line of symmetry is going to be right here on this red line, this line. Between this -2 and this -2. So the line of symmetry is x value between 0 and 1. That's a half. So it's x equals a half is the line of symmetry. X equals a half. And you want to know the y value for this, you can plug it into the function to get the y value there. Right? To know what the y value is here, which is the y value at the turning point. Plug the half in this. So the y value here is going to become a half squared minus a half minus 2. What that work out to? What that work out to? This is -2 already. This is a quarter minus a half. So it's a quarter minus a half, and a half is 2/4. So it becomes minus another quarter. So it is actually -2 1/4. So the turning point is at -2 1/4. Half minus 2 1/4. All right, that's where the turning point is. So the axis of symmetry is right here on this line, halfway divided. But it's over here is 4. So if you want to work out this value as well, you could put the -2 in the function. Trust me, it's going to come out to 4. You can work it out if you want. So the value for here, if you want to work it out, would be -2 squared minus a -2, and then minus another 2. All right, so this works out to be a 4. This minus becomes a +2, and then subtracting this 2. So you see, this is why I put each other left with a 4. We could use it, the symmetry of the values and know that it was a 4 from the get-go. But let's continue. I want us to draw the graph now. Them say use what? Them say 2 centimeters to 1 unit. 2 centimeters to 1 unit. This is the red. So this is 1, 2, 3, -1, -2. This is 1 on the y-axis, 2 on the y-axis, 3 on the y-axis. What's the maximum value? Go up to 4. 4 on the y-axis. And this down here is -1, -2. Let's draw the graph in blue. Let's plot the points in blue. So the first point was -2, 4. -2, 4. -2, 4 is up here, so right here. -2, 4 is right here. Next point is negative 1, 0 on the x-axis. Negative 1, 0 is right here on the x-axis, right here. On the x-axis, right here. Next point was 0, negative 2 on the y-axis, right here. 0, negative 2 is right here on the y-axis, right there. Next point was 1, negative 2. See there, 1, negative 2. The values are symmetrical. 1, negative 2 is right here. 1, negative 2, right here. The next value was 2, 0, right? See there, 2, 0, which is on the x-axis again. That's another root. The last value was 3, 4. 3, 4 is up here. And because we know it as a vertex point, our vertex point can have this x value and this y value, negative 2 1/4. Right? Right in between here. The axis of symmetry is right in the middle here. So that's a line of symmetry. Divides the graph half and half. So the values over here are the mirror image of the values over here in that line. So our turning point is on this red line down the middle. Half minus 2 1/4. So let's see what 2 1/4 would be. All right. So right here, we minus 2 1/2. Because this is minus 2 1/2. So minus 2 1/4 will be right here, halfway between it. So it means that our turning point is right at this point. So that point right there is half minus 2 1/4. That's the turning point. So if you bring a graph to turn right at that point, all right? Minus 2 1/4. Let's mark that point in blue as well as a turning point. You have to bring it down here to turn. So draw a smooth curve through these points now. And we have our curve. CSEC maths paper leak again. I'm gonna tell them. CSEC work this bad man. So I scrap the multiple choice this year and I'm dead. No multiple choice this year. Paper 2 only. Hey. Anyway, we don't know what they're gonna do. But that is the curve. And it done. All I wanted was to draw the curve. Easy question. Number 9. 2 questions ago. 9 and 10. Online is still there. Students online still there?
Yes, sir.
All right. Hope you're marking, you know. I hear some 90 again today. People that may say that P90s them get, you know. And 80s, you know. This question said, WX and U are points on a circumference. It says TV is a tangent. This line is a tangent at the circle at U. It says UW is a diameter. That's a diameter. The diameter subtends 90 degrees. And that a triangle is isosceles. This triangle is isosceles. All right. So these two sides equal. So therefore, these two angles equal. All right. Question says, use appropriate theorem. Using appropriate theorem, state 3 reasons to explain why the angle Z is 45 degrees. Why is this angle 45 degrees? State 3 reasons why it is 45 degrees. All right. To do that, I'm going to populate the diagram up here with some information to help us. All right. Populate the diagram with some information to help us. So firstly, I'm going to first tell him that this angle is 90 degrees. Why is that angle 90 degrees? Because it's subtended by diameter. So I'm going to write that. I'm going to say that first. Angle, okay, actually drawing it in. This angle right here is 90 degrees, but it's subtended by the diameter. And then now I'm going to say that these two angles equal. This one and this one equal 45 each. Why? Because that's an isosceles triangle. So I'm going to say as well that this angle is 45 degrees. Why is it 45 degrees? Because total angle in this triangle is 180 and the triangle is isosceles. I'm going to say it is equal to 180 degrees minus the 90 degree over here divided by 2, which is 45 degrees. I'm putting all this information on my paper to help me. All right, makes my explanation easier. All right, so those two angles equal 45 degrees. All right, those two angles equal 45 degrees that I've marked. I'm ready now to give the reason why this is 45. The first reason I'm going to give it that it is 45 because it's the angle between the tangent and the chord equals the angle subtended by the chord over there. See that? Good? That's the first reason. So it is equal to 45 because angle between tangent and chord equals angle subtended by the chord. That's the first reason I'm giving them. Next reason I can give them is that this is 45. I'm going to tell them that this is 45 as well, right here. So this is angle is also 45. So I'm going to put the arrow down here so that this angle is also 45. So this angle is 45 for the same reason. Oh, I didn't put the reason. Isosceles triangle, right? Isosceles triangle. Isosceles triangle. Isosceles triangle. Total angle is 180 degrees. The isosceles and the total is 180. So that's my other reason why that is 40 degrees, 45 degrees. So that's 45 degrees. And then now I'm going to say that this angle now is 90 minus 45 because the angle between a tangent and a radius is 90. All right? So I'm going to say angle between tangent and radius is 90 degrees. That's another reason why that is 45. So angle between the tangent and the radius is 90 degrees. And so the Z is equal to 90 degrees minus the 45 degrees in the triangle, which is 45 degrees. That's the second reason. The angle between the tangent and the radius is 90. And this in here says 45, as I showed in red. So this here must be 45. That's the next one. The next reason I'm going to say that that is 45 because total angle on a straight line is 180. So therefore, I'm going to also indicate on this diagram, is a different color, that this angle over here, is 90 right here. I'm going to enter this angle as 90 as well. So I'm going to say this angle is 90 degrees. Angle between tangent and radius. That's why this angle here says 90 degrees. That's what I'm telling you. Then I'm going to say now Z equal 180 minus a 90 and a 45 here because of total angle on a straight line is 180 degrees. That's my third reason. I'm going to say that the Z angle is also equal to 180 degrees minus the 90 degrees and also minus the 45 degrees on the line, which gives us still 45 degrees because total angle on a straight line is 180 degrees. 3 reasons I gave them. But I helped me by populating the diagram with some of the information first. So it becomes easier to show the reasons. Get me? Become easier to show the reasons. Next question. It says, part B says, the diagram below shows a circle with diameter KF. That's a diameter. Remember, it's a diameter sub 10 90 degrees. Yes? Huh? Right? And says the line EFG is a tangent at F, and the points F, H, K, and J lie on a circumference. It said, by showing each step in the working where appropriate, find the value of each of the following angles. First angle I want is X. This angle X. Easy. X is subtended by this chord. The same chord is subtending an angle 56 up here. Same segment rule. So the X up here is equal to the 56 up here. Both of them subtended by the same chord. So X equals 56. So X equals 56. All right, so X degrees equals 56 degrees. So why is the reason? Angles in the same segment are equal. Angles in the same segment rule. In the same segment are equal. Angles in the same segment subtended by the same chord are equal. All right. Next one, angle Y. So now know that this angle is 56. Let's put on the diagram. So we're talking about youth. Jesus Christ. This angle is 56 degrees. Can't even whisper. So what is now? So you see this Y angle here, so it's an external angle of this triangle. Look at it. Can't wait for next week coming on though. Can't wait. Tired of that class. Tired. I'm teaching hard. I'm teaching fun at all in class. That's an external angle. So see this angle right here, this external angle is equal to the sum of these two opposite interior angles, this one and this one. Sum of them. So Y equals this plus this. Simple as that. External angle is equal to the sum of the two opposite interior angles. So it equals 56 plus 19. So the Y equals 56 plus 19. Y degrees equals 56 degrees plus 19 degrees. That is 75 degrees. Why? Because the exterior angle of a triangle equals the sum of the two opposite interior angles. That's it. Then we'll come to this bearings question. We have some elevation on it. So the diagram below shows 4 points, P, Q, R, and S on level ground, where pillars will be placed to mark the outline of a foundation. So P, Q, R, and S. All right? There's no bearings in it actually. It's not bearings, it's elevation. I said there's a vertical post RT. Right here, there's a vertical post RT. All right? It says from Q, the angle of elevation to the top of the post is 21 degrees. So from here to the top of the post, so that is a vertical post right here, but you can't see it, you know, because it's like you're looking down on this diagram from the sky. So if you look at it from the side here, Then you're gonna see the post like this. Let's draw it over here, so. Look at it from the side. The vertical post, T at the top, R at the bottom. Then you have this horizontal ground, RQ is on the ground. So Q is out here. So Q is out here. And this distance is 153 meters. 153 meters. And basically telling us that the angle of elevation looking up here is angle of elevation looking up here. Angle of elevation from Q to T. It's telling us that that angle is 21 degrees. Angle looking up here is 21 degrees. So this angle is 21 degrees looking up. We have this distance. What they're asking us for, find the height of the post. They want to find that height. Let's call it H. So we can reference it, H. So in this, that's a right angle triangle now because that's a vertical post and that's horizontal ground. So the angle inside here is 90 degrees. Angle between vertical and horizontal is 90. So to find that height, we're going to use tan, opposite and adjacent, connected with the tan trig ratio. And with a right angle triangle, so we can use SOHCAHTOA to wind it. So it's going to be that the tan of the 21 degrees equal the opposite H over the adjacent 153. So to find the H, we take the 153 and multiply it over here. So we're going to get, let me make this shift this over a little bit. It's a little bit smaller. Right. So we make H a subject, multiply this up here. The H is going to be 153 times the tan of 21 degrees. Therefore, that height is obtained by working this out. Simple as that. I think it's the last paper I work out. I work on more paper for 153 times the tan of 21 times the tan of 21. That becomes 58.7. 58.7 meters. See, 3 significant figures. Answer is not exact. 3 significant figures. That's the height of the post. Next question says, given that the length of QS is 135 meters, calculate the perimeter of the foundation. Let's look at it. QS is 135. Let's put on the diagram. QS, that's this side here, is 135 they just gave us. This is 135. No, they want the perimeter. The perimeter is the distance around the thing. This plus this plus this plus that. We know 3 of them. We don't know this one. We have to calculate that one in order to get the perimeter. This cannot be added to the perimeter. Perimeter is the distance around. To calculate this side over here that we don't know, we're going to come and work in this triangle. And that's why they gave us this distance. Let me take this off now. We need to find this length here that I'm marking out in red. That's the only length that we don't know. Work in this triangle. We're going to use the cosine rule. We have 2 sides and an angle between. So it's a cosine rule question. Cosine rule to find this side over here. 2 sides and an angle between. Come on, man. Exam next week. I'm still talk foolishness. Sure. Just a class I get my cross, you know. You have a sine rule, man. Sine rule is used when you have an angle and a side opposite each other that you know both of them. One angle that we don't know the side across from it. So you can't have the sine rule. How much time I say the same thing? Jesus, peace. Anyway, cosine rule to find this side, right? So it's like Pythagoras' theorem. So PS, start like Pythagoras' theorem. It's going to be the square root of this side squared plus the 135 squared that they gave us a while ago. Let's write it back. 135. This side is 135, that's it. meters. So you have two sides and an angle between them. So it's cosine rule, man. Come on. Exam is next week. Them set this thing every day. And I still have right to talk foolishness for this. 83 squared plus 135 squared. Then subtract a piece, but it's not Pythagoras' theorem. So you have to subtract a piece. Let me shift this down a little bit. Every class, I want to get me mad in our class here. So, minus 2 times the 83 times the 135 times the cosine of the 29 degrees between them. Cosine of the 29. Shift this over some more still. Cosine of 29 degrees and everything under the square root sign. That's why you calculate this length, RS, PS that you don't know. So you can add on the rest of it to get the perimeter. That's the length that we don't know. So that calculation will give us that value. It's down here where I want it, down here. You put this in a calculator, you get PS. All right. So it is a square root of 83 squared plus 135 squared minus 2 times 83 times 135 times the cos of 29. 74.3. Yes. Yeah, mommy, no. Now wait till the week before exam to figure out how to put this after all the 1 million them question. And the week before exam, you want to figure out how physical calculator put this in, and this have to go in almost every exam paper. You have to enter something like this in one calculator. I still not do it yet. .3 meters. And you want the perimeter, now you add up everything. So the perimeter then equals. So I don't know where you get syntax. The first time you do one of them calculation in a calculator. Huh? You're asking for the first time you do one of them calculation in a calculator. So where you get syntax error now? Frustrate me in another class. Yeah. The other part of the size now, right? This side is now 73 point something. 74.3 meters. The other part of them now. So we're gonna add up the 83 meters here, 153 here, the 110, and then the 73.4, 74.3. That's what we're gonna add up to get the perimeter. You got it, Steer? Thank you very much. Give me a little hope. Give me a little bit of hope, my boss. Give me a little hope. That's 420.3 meters. If you just put 420, that's okay. That's 3 figures that. That's a perimeter. Last question. Now we can get out of here. Matrices. The 3 matrices, Q, R, and S. And I say, explain why the product QS is not possible. And them questions supposed to apply to them questions now, you know. Second nature, you know. So the Q is a 2 by 2. And the S is a 3 rows by 2 columns. A 3 by 2. This is not conformable because the number of columns here, the number of rows here, they are not equal. So the number of columns in Q is not equal to the number of rows in S. That's why it's not possible. Number of columns in Q is not equal to the number of rows in the second one, which is S. Number of columns in Q not equal to the number of rows in S. That's the reason. Next question. State the order of the matrix for the SR. So S is a 3 by 2, right? And R is a 2 by 2. So that will be a 3 by 2 times a 2 by 2. This is possible because these two equal. And the result will have the same order as these two. The answer will take this by this. Number of rows at the first by the number of columns at the second. So the rows is going to be, the result is going to be a 3 by 2 as shown in purple there. Takes the number of rows at the first and the number of columns at the second. So that's the answer. Going to be a 3 by 2 matrix. Then it says calculate the matrix product QR. Let's multiply the Q times R. What is the Q? The Q is 2 minus 1, 4, 3. 2 minus 1, 4, 3. And the R is what? The R is a 1, 6, negative 5, 4. 1, 6, negative 5, 4. Multiplying those two matrices. Remember, we use the rows of the first matrix and the columns of the second matrix. I'm going to fly through this because I must master this by now. If I master this by now, can't put it again. This has 4 values. There's so much a teacher can do and no more. I tell you, I reach my limit in our class. I reach my limit. So this first value is obtained by multiplying this first row by this first column because that's where it is located. First row, first column. So it's first element times first element, second element times second element. First element times first element, second element times second element. 2 times 1 is 2, minus 1 times minus 5 is a positive 5. This value over here now is first row, second column. So using this first row with this second column. First element times first element, second element times second element. First element times first element, second element times second element. 2 times 6 minus 1 times 4. 2 times 6 is 12. The minus 1 times 4 is negative 4. Let's shift over this bracket. That's always happens. Then this value down here now, this one. It is in the second row and the first column. So using this second row with this first column. First element times first element, second element times second element. First element times first element, second element times second element. 4 times 1, 3 times minus 4. 4 times 1 is 4. 3 times minus 5, negative 15. Then this last value down here is in the second row, second column. So using this second row with this second column to get it. First element times first element, second element times second element. First element times first element, second element times second element. 4 times 6 and 3 times 4. The 4 times 6 is 24. 3 times 4 is 12. So you're adding 12 to that. Shift this bracket again. can write the final answer here. So this is 7. 2 and 5 is 7. 12 minus 4 is 8. 4 minus 15 is negative 11. 24 and 12 is 36. That is the matrix. What else I must do? It says this matrix has a determinant of 5. So determinant is 5. This means determinant. All right? So what is the determinant? The determinant is this product minus this product. So the determinant of A is 5. What's the determinant? This product is 4 times x minus this product is a positive 7. Negative 1 times negative 7 is a positive 7. So we're subtracting 7. That is equal to the 5. Throw over the 5, we get 12. So 4x equals 12. And then divide by the 4, you get 3. X equals 3. Done. Then we'll come to this vectors question. Question says, in the diagram below, OPQ is a triangle, ARB and AOQ are straight lines. B is the midpoint of PQ. This is the midpoint of this line. So it's cut it in half. R is the midpoint of AB. R is the midpoint of this line AB. Cut that line in half as well. It says OR to RP is 1 to 3. This line is broken down 1 to 3. So it has 4 parts total. OR is 1 part down here. RP has 3 parts up here. So it means that this part, for example, is 3/4 of the whole line. And this part down here is 1/4 of the whole line. The line has 4 parts. 4 parts. 1 part down here and 3 parts up here. So it's a 1/4 of the line that, 3/4 of the line that. Good. Then it says the vector OP is 4A. The world's vector 4A, OP is 4A. So that makes it easy, you know. If the whole thing is O is 4A. Right? And this is 1 part. And this is 3 parts. That means that down says a vector A. Remember the whole thing is 4A, you know. So this is vector A. From here to here is vector A. So this is vector A actually. Don't put on in red. Don't put on in red. Because only says 1 part and the whole length is 4. This is 1 part out of the 4. So this vector is A. And up here says 3 out of the 4 parts. So the vector up here so is 3A. This up here must be 3A. So they give you a nice value. This up here is 3A. So you get a 4A, A plus 3A. The whole vector is 4A. And it is in the ratio 1 to 3. So it's easy to break down. Easy. And then I said the vector OQ is 8B. So this vector out here so is 8B. Let's put it down. This vector out here so is 8B. All right? Underline the vector components. All right. Question says, find in terms of A and or B, the vector PQ. So go from P to Q. Let's look at the diagram. Easy. When I use the diagram, you know, everything is, well, we can use position vectors for this one. Okay, we know the position vector of the P and the position vector of the Q. See them here? They're up here, so. This is the position vector of the P, that is the Q. So when we know them, we can just calculate it using O times the last minus O times the first. OQ minus OP. So the OQ is this one, 8B. Minus OP is this one, 4A right here, so 4A. If you wanted, you could have looked at the diagram and said, how do I go from P to Q, going along the vector direction? I would have come down here so first with a minus 4A, and then go straight across here so with a plus 8B. 8B minus 4A, same thing we write as well. 8B minus 4A. But because you have the position vectors, you don't need to use a diagram to do it. Eh? So remember now, it's like we now know this vector now. We have it now. This vector down here, we now have it. We know it. See here, so we have it. We have that vector over here, so now. So we can travel along it. Remember then also that right here is just half of it, half of the whole thing. Easy. Let's see what they want us to do next. They want the vector PR. Let's look at the diagram. What is PR? P to R. So P to R, it's on the diagram. It's just minus 3A. P to R, it's just minus 3A, going in the opposite direction. That's what I'm saying, and or now. A and or B. So P to R is just minus 3A, because going in the opposite direction. So this is just minus 3A. Done. No calculation needed. It's on the diagram. Right? That's PR. That's a free question. Next one. RB. Let's look at the diagram. How do we go from R to B? From R to B. So we know PQ, you know, we know PQ. So go from R to B, we're gonna come up here so first, and then go down here so. Let's do it on the screen right here so. So to go from R to B, we're gonna go R to P first, using the 3A, and then we're gonna go from P to B. Remember that the PB is really half of the PQ, you know, which we know down here so. So this PB is half of PQ. So this then is going to become R to P. And then this PB is half of PQ. All right. So see here now. The R to P is this 3A right here. So 3A. Plus half of PQ is half of these values. Half of the 8B is 4B. Half of the minus 4A is minus 2A. Then consolidate the values. 3A and minus 2A is a A. Plus back this 4B. That is the answer now. You can check it up the diagram if it makes sense. This is basically saying to go from R to B, we must go a A and then a 4B. Let's check if it makes sense. Let's check if it will work for true. So we're gonna go like an A. Remember the A is just this long enough. Let's do it in red. Just check it. So you're going to allocate A like that, which is about to here. That will be about an A. And they're gonna go 4B, which is now half of this line. See there? Straight across. See there? That's about a 4B. And this is about an A. So you cannot accept an answer like that. This is what the diagram is showing us. Right? It's consistent. So this is a solution for that part. Question done, paper done. Class done. All right, let me hear some grades now. Let me hear some grades. That is it. Hmm? 100%. These recent papers are marked out of 100. So they're easy to grade. 100 marks. So add up your marks, add up to 100 marks. 100 marks. Easy to grade. I want to flex. I want to flex my loving. Leave here, come here, man. Where you go? You know, show me where you calculate where you do the foolishness. Come on. You want to go in the exam and do foolishness? Huh? You want to go in the exam and do foolishness, son? Come see me, show me the foolishness where you do the calculate. Online, let me hear your grades, please. Online. Let me see, put in this message. Where question there? How much you get? Never do the paper?
No more do the paper, but it's never
You don't beat me, I do the stick, you know. Put in this message. Put in this expression in the calculator. Let me see this right here. Online, I want to hear your grades. Elizabeth, how much you get? Alexia. Jackson. I don't know his card. How much you get? Let me see.
Sir, 95.
Who that get 95? Let me hear you. Who that?
Sir, guess.
They say, should I do the exam? I beat you with I do the sticking. Turn all like that. Tell the parents to vex, you know. Say, now do the exam. Tell them. Turn all like, no, turn all like. Can't see this.
Okay, sir.
Alright, make sure the next year 100 I get next year 100.
Yes, sir.
So when I get it. Ever you get? Enter it again. You never put a bracket at the end of the 29. What you get? 77? It's not so bad.
So that's it.
Better than last. So the question I make, beat the man and get the right thing before you leave. The question I get right, do them over, yeah?
You have no more of the printout copy?
I'm not sure. I'm going to check the car. Press equal now. Press equal now.
Yeah, and it worked.
You work now? So that's it.
What would you do before?
You have a bracket it. You have a bracket the degree.
So what would you do so? So that's just so get that and then wait.
You have to learn the calculator and you have to learn everything about your calculator.
You just find out where
You get it now. Alright. Huh? What? Need for market?
No,
So where's the paper? Huh? Leave it. Oh, that just gone to the go. Call a person.
by the way, sir, put the same up the extra copy. But I get it. Wednesday one, I'll get some extra papers.
Which one's the paper? All the people in the WhatsApp group, man, you just looking at the group. Every single paper in the group. Huh? Yeah, but I don't have it. It's all gone. It's all gone. Another thing that I want to go. Let them go on. They're not serious. Come now. Come tell me what you're going to get. Alright. Huh? I go step up and I hear the 5 and I forget to know. Hear the 5. And show it's a 95 and I get weekend up coming in. 89. Alright. What's it get? Oh. Where the other young girl? What's her name? Louis.
Sir,
Yes?
I didn't get to finish because I was trying to study for my other exams.
You have to finish a couple papers before the real exam next week, you know.
I know, sir, but I had an EDPM test and I was trying to get some last minute studying done.
Alright. Alright, cool. We're doing another paper this Wednesday. And we're doing 2 papers Saturday. You have to finish them.
Yes, sir.
Saturday next week, yeah. Alright, guys, I'm ending it now. Jackson?
Yes, sir.
How much you get? You do that paper here too?
No, sir.
Alright. Oh, you're gone in a terminal grade. Why do I have the paper? Huh? Them search your bag. What's that? We don't carry exam. You don't carry bag when the exam room. You do not carry a bag in the exam room. Look here, man. Tell me no foolishness. You think I hear that?
Sir, there you go. They sit the table at the front of the class and we carry our bag up to the front of the class.
The bag is over there somewhere and you go in the exam room to do the exam. So if you leave your bag up there, so, and you don't necessarily do the exam, how you can go in your bag or do it?
No, sir, that's the they
search your bag and make it take out what? So you tell me, so one empty bag you put down? That's what you're telling me? Anyway, you're a joker still, so I'm not surprised. That. Where say it, youth? Done, Mark? Alright, guys, I'm going to hang up now. See you all on Wednesday and Thursday. All right, bye.
Bye, sir.
Boy, Elizabeth, Mr. saying how the exam, I tell her. But anyway, so you go. All right, bye.